Hi everyone, my name is Boyeon Choi. Today I will talk about the evolution of the protocol suite as envisioned by DARPA, the Defense Advanced Research Projects Agency. Our presentation aims to explore how the Internet architecture design evolved from its initial design objectives to its current state, while also shedding light on the challenges faced and the innovative solutions implemented along the way. DARPA set the goal of Internet architecture to develop effective technologies for multiplexing existing connected networks. And these are detailed objectives to achieve that goal. Objective 1. Internet communication must continue despite loss of networks or gateways. Objective 2. The Internet must support multiple types of communication service. Objective 3. The Internet architecture must accommodate a variety of networks. Objective 4. The Internet architecture must permit distributed management of each resources. Objective 5. The Internet architecture must be cost-effective. Objective 6. The Internet architecture must permit host attachment with a low level of effort. And finally, Objective 7. The resources used in the Internet architecture must be accountable. Each listed in order of importance for Internet architecture design, and these objectives served as important guidelines for designing the architecture. Now let's look at how these objectives led to challenge and innovative solutions. Objective 1, which was about resilience despite network failures, posed a significant challenge. How could we ensure Internet communication continued despite network or gateway failures? Firstly, some network architectures stored state information at intermediate packet switching nodes. However, protecting information from loss, where replication might not be provided for protection post-problem. The solution to this challenge was the concept of fate sharing. It involved collecting state information at host, providing protection against intermediate failures and simplifying engineering. And moving on to Objective 2. The Internet must support multiple types of communication service. Initially, TCP seemed suitable for providing transport services at the level of remote login or file transfer, among other applications. It was expected that TCP could support all types of services within the architecture. However, challenges arose due to TCP's nature. To overcome this, TCP and IP, initially a single protocol within the architecture, were separated into two distinct layers. Objective 3 revolved around integrating various network technologies. Regarding the third goal, integrating various network technologies was essential for the success of the Internet architecture. For this, the Internet architecture required the assumption that networks could deliver packets or datagrams with reasonable but not perfect reliability. Objectives 4 to 7 also had significant impact on the design and operation of the Internet architecture, but there was a difficulty in solving all these goals. Firstly, distributed management was achieved by not having to implement and manage networks and gateways in the same institution. However, cost effectiveness was not resolved. The Internet architecture did not always utilize resources as efficiently as custom architectures in some circumstances, particularly when sending short packets. In addition, the issue of retransmission overhead was also a problem, as packet loss recovery occurred at the endpoint, which resulting in redundant traffic. Furthermore, to provide desired types of services at the host level, all mechanisms have to be implemented. This could lead to lots of effort for connecting hosts to the Internet architectures. And lastly, accountability for packet flows remains an ongoing research challenge as the Internet architecture lacks good tools for accounting for packet flows. It is a task we need to solve in the future. Next, I will talk about flexibility and use of datagrams, which are important elements for Internet architecture. The Internet architecture's flexibility in providing services was both a strength and a challenge. It allowed a range of protocols and networks that led to provide a variety of services, but service levels could vary significantly depending on the implementation. As the result, addressing performance issues would be difficult due to the architecture's emphasis on flexibility. And in addition, it had to be handled in a way that specific performance requirements for specific implementations in order to clarify performance constraints, but it was difficult to provide guidance within the architecture. Next, the use of datagrams is a key feature of the Internet architecture. It does not require a connection state within the intermediate switching nodes, so there is no concern about the state when requiring the Internet after a failure. And datagrams serve as basic building blocks for implementing various types of services. Finally, datagrams allowed for multiple types of networks through minimal network service assumption. In conclusion, we have covered each initial objectives, challenges, and solutions that have shaped the Internet architecture as we know it today. TCP and IP's evolution has been marked by innovation and adaptability driven by DARPA's initial objectives and the need to overcome various challenges. Ongoing research challenges such as achieving cost effectiveness and improving accountability for packet flows is our work to solve from now on. This is the end of my presentation, and thank you for listening.